Good afternoon, everyone. Welcome to the Steel Structural Design class. Today, the topic is designing the beams. But before starting the main part of the lecture, let's overview what we covered last session. So last week, I explained that in steel structures, we basically have two main kind of elements, the horizontal ones and the vertical ones. I mean the beams and the columns. Here in this picture, you can see a net of beams and columns that are connected to each other. Beams carry the roof's load and columns carry the beams load. So finally, down here you can see the foundation. The foundations carry the loads of the columns. In these three pictures, you can see the connection between different beams and columns. So for today, I specifically want to talk about designing process of I-shaped beams under the vertical loads. So say for example, we have a beam like this. It has two supports and it's under the vertical load. That in this example, it's a distributed load. So we want to design this beam, but what does actually designing mean? Obviously, it doesn't mean the architectural designing of a beam. So here, when we say that we want to design a beam, it means that we want to find the required dimensions for the cross section, that this beam can carry the loads that is on it. So for example, here we have an I-shaped beam. So when we design it, we want to find the height of that, the width of that, and the thickness of the flanges and the web. But as you know, it's very hard to do all of it by hand. So there are tables that can help us in this process. So like the table that I gave you last session, we have tables that they have the properties, all the properties of the different sections. Say for example, here we want to design our beam from IPE. And when we do the designing process, we can calculate the required W. W is the section modulus. And when we calculate that, we can find, using this table, we can find the IPE that has a W bigger than this number. So when we get this number here, I mean, when we find the number of IPE, the designing is done. And we have found the section that is strong enough to carry the load. By the end of this session, I expect you to be able to analyze the beams under the vertical loads. So when you have the loads, when you have the geometry, and when you have the boundary conditions means the supports. You should be able to find the maximum moment that is applying on the beam. When you find this maximum moment, you should be able to use the designing criteria to find the required section modulus. And after that, when you have the W, you should be able to use the table to find the number of IPE that is required for this for these loads. Okay, so let's start the main part of the section. So today's topic is designing an I-shaped beam under the vertical loads. So we know that we have a steel beam, it's I-shaped, and the loads are vertical. So we want to know how we can design that beam for that loads. The designing process has two steps. The first one is analyzing. So say for example, we have a beam like this, and it has two supports like this, for example, two hinge supports. It can have another support in the middle or something else, and it's under some loads. For example, in here we have a distributed load with the magnitude of Q and a point load. We can have other combinations of different loads, and the length of the beam is L. Okay, so in the analyzing part, we should have, as I said, the geometry in general, the length and the dimensions. We should have the loads that are applying on the beam. And finally, we should have the boundary conditions. Okay, when we have all of these together, we can calculate the maximum moment that is applied on this beam. So here we have the output of this part is the maximum M. When we have the maximum M, we can start the second step, that is designing. Sorry, B. Okay. This beam is under the vertical loads, and therefore we have moment on it. And the hysteresis that are induced by the moments can be calculated by this formula. F, which is hysteresis, is the maximum load, maximum moment that we calculated, the last step, divided by W. W is the section modulus. And actually the goal of this process is just to find the required W. So W, which is section modulus, is the goal of this designing part. So to have a safe design, the actual hysteresis that are applied on the beam should be less than the allowable hysteresis. So here allowable hysteresis is 0.6 times yield hysteresis of the steel. So the material that we have has a specific yield strength, that is FCY. So we multiply it by 0.6 to find the allowable bending stress. But we have actually multiplied this yield stress with a number that is less than 1. Can you guess why we have done it? Any idea about it?
Does it work as a safety factor?
Exactly, because we want to make sure that the beam is strong enough and the design is safe. So we multiply the yield stress with a number that is less than 1. I call this equation equation 1 because later on we will use it to design an example. So now let's solve an example together to understand the process better. So here is an example. Say we have a beam like this, and we have 2 hinge supports at the end, and it has a length of L, and it's under a vertical load that is distributed and it's uniform and has a magnitude of Q. So now we know the L, we know the boundary conditions, and we know the load that is applied on that. So they are given. So they are the information of the problem. So here Q, for example, is 4,200 kilogram per meter. And L, which is the length of the beam, is 6.5 meters. And FCY, which is the yield strength of the material, is 2,400 kilogram per centimeter square. Okay, so these are given and we know all of them. What we want to do is to find the required W, and therefore we can use the table to find the IPE number that we want. Okay, so let's start to solve it. As I explained here, when we have geometry, when we have the loads, and when we have the boundary condition, we can calculate the maximum M. So here we have 2 simple supports at the end. We have length of L, and we have a uniform distributed load. So I can calculate the maximum moment. Can you remember it from the structural analysis that in this case, how much is the maximum M?
Yes.
Okay, how much?
QL square over 8.
Exactly. So, when we plug in these numbers, I mean the Q and the L, we can calculate a maximum moment, which is in this case is 182 kilogram meter. Now I have the moment that I want to design the beam for that. So I can start the second step, that is designing. Here we want to find the W. In this formula, I know maximum M, I just calculated that. I know the yield stress is given. So the only thing that I don't know is W. So if I bring it here, I can, and bring this one here, I can calculate the required W. So the required W should be bigger than maximum M divided by 0.6 times FCY. FCY is here, is given, and I calculated maximum M. So if we plug in all of this number here, we get this number, 1540 cubic centimeter. Now I have the W that is good enough and that's safe enough for this beam. When we have this number, I can use the table that I gave you in the last session to find the IPE number that is that has a W bigger than this number. So here in this table, in the first column is the IPE number, and in the seventh column is the W that is for that column, for that section. So we are looking for a W that is bigger than this number. So if you follow this column, you find that the IPE 500 has a W bigger than this number. So I will use IPE 500. Okay, so that's all. The designing process is done. So let's review what we did here. At first, considering the boundary condition, I mean the supports and the loads and the geometry of the problem, we calculated the maximum moment. Maximum moment is actually the moment that we design the beam for that. When we have it, we use the designing criteria that is here is for bending, and we should follow this formula to find the IPE that is required for this beam. Okay, what I want you to do is at first, any question so far? Okay, great. What I want you to do here is at first go through this problem one more time and make sure that you understand everything in that. And after that, I want you to solve a homework. So the homework is for next session, and it's say we have a beam like this, the same boundary conditions, but this time we have 2-point loads like this. They have the same magnitude, and this is 2 meters. In the center we have 3 meters, and at the end we have 2 more meters. And P is 10 tons. So I want you to design this beam and hand in your solution for next session. What we are going to do after that is just to solve the problem for the beams that have different boundary conditions, and that's it. So please, if you have any questions, send me an email or stop by.